The issue of climate change is a very hot topic both in the scientific community and in political arenas. The reality is, whether we believe there is a crisis or not, the effects of climate change is becoming more tangible. While the most popular remedy to this issue is the curbing of carbon dioxide emissions, a more radical solution could be geoengineering. But what is geoengineering? Could it be the untapped solution to climate crisis? The term geoengineering first became known in the 1970s when an Italian physicist proposed the injection of carbon dioxide into the ocean to counter the impact of fossil fuel use on the climate. In 1992, the use of the term became more common because of the publication of the Panel on Policy Implication of Greenhouse Warming. The modern definition of geoengineering is the deliberate, large-scale intervention in the Earth's natural systems to counteract climate change. Geoengineering has two branches. The first is called solar geoengineering, also known as solar radiation management or SRM. Most methods under the SRM include the deploying of space mirrors or reflectors in the lower Earth orbit, the introduction of sulfide aerosols in the stratosphere, the atomizing of seawater to brighten marine cloud. All of these reflect a portion of the sun's energy back into space so it will not reach the Earth's lower atmosphere. A few more SRM methods are releasing microbubbles to achieve the ocean mirror effect, painting most roads and buildings white to increase reflectivity, planting bioengineered high albedo crops. All of these methods aim to reflect the sun's energy so that the ocean and the land will not absorb the heat, thus minimizing temperature rise. The last method under solar geoengineering is the thinning of the high-altitude cirrus clouds, which would allow more heat to escape into space. This in turn would cool down the planet. The second branch is called carbon geoengineering, more commonly known as carbon dioxide removal, or CDR. As the name implies, this branch aims to lessen atmospheric carbon content either by physical or chemical means. CDR methods include the afforestation of barren lands and reforestation of denuded areas, fertilizing the ocean with iron sulfate or urea to encourage the growth of phytoplanktons, which use carbon dioxide during photosynthesis, dissolving rocks and minerals in the ocean, which can enhance its alkalinity and counteract acidity, the use of artificial trees, and direct air capture technology to scrub off carbon dioxide from ambient air, biochar, and the extraction of bioenergy from biomass, which both capture carbon dioxide and convert it to a form which can be safely stored underground. Despite all the positive intentions in the geoengineering proposals, there is opposition to the idea. The main reason for that objective is that geoengineering detracts from efforts to minimize carbon emissions. Many believe that the financial resources and time being devoted to geoengineering should be used to help achieve the goals of the Paris Agreement. Another reason is that most of the proposed methods are available only in laboratories as prototypes. The deployment of these untested methods can yield unintended consequences, like the depletion of ozone layer due to the sulfides in the aerosol, or the overgrowth of algae in the ocean. Currently, there is no governing protocol in place with regards to geoengineering, and many fear that this can cause international tension or disagreement. The central argument of the opposition is that humans should not tamper with the climate anymore. We have already done enough damage. On the other hand, proponents of geoengineering cite the uncertainty in the timeline and result of cutting carbon dioxide emissions. Currently, the goal of the Paris Agreement is to limit carbon emissions by 20%, but it is unknown how much this will affect the average global temperature. The target timeframe of the Paris Agreement is the mid-21st century, but this is a moving deadline. The second advantage of geoengineering is its cost-effectiveness because of the use of very common substances like salt, iron, or rocks in its processes. And, unlike the reduction of carbon dioxide emissions, the effects of geoengineering is more immediate. For example, direct air capture method almost instantaneously removes carbon dioxide from the air. Proponents of geoengineering believe that this is our chance of correcting the problems we created. Still many questions arising from this topic. Should we wait for the result of the Paris Agreement before we utilize geoengineering? Could we use geoengineering to complement the reduction of carbon dioxide emissions? Can the benefits of geoengineering outweigh the possible risks? If you want to learn more about this topic, here are the reference materials I used. I also included a link for each source in the description box below. Please don't forget to comment on our discussion board. This is Gillian Owens, and thank you for watching my video.